We are now demonstrating the CL45 cleaning procedure for a radiator cap type cooling system, also known as a radiator cap refill cooling system. Before starting the procedure, make sure the engine has completely cooled down before opening the radiator cap. The hose connecting the reservoir tank to the radiator should also be clamped. This prevents coolant from being drawn back from the reservoir tank and ensures that the coolant being extracted comes from inside the radiator. This kit includes 3 sizes of radiator cap adapters, allowing you to choose the most suitable adapter for each vehicle model. After selecting the correct adapter, install the radiator cap adapter onto the radiator filler neck. Next, attach the 90-degree fitting to improve hose routing and prevent the hose from kinking. The purpose of these fittings is to allow the machine to extract a portion of the coolant through the radiator opening. Since the reservoir hose has been clamped, coolant will not be drawn back from the reservoir during extraction. At this stage, we will use the machine's green hose. Connect the machine's green hose to the radiator cap adapter that was just installed. Before starting the extraction process, make sure the drain valve at the rear of the machine is closed. If the rear drain valve is open, the liquid inside the 2-liter transparent tank will flow into the waste tank below. Therefore, the rear drain valve must remain closed during vacuum extraction. If the valve is not closed, vacuum pressure will leak through the drain line, resulting in insufficient suction or failure to establish a proper vacuum. So how much coolant do we need to extract? The purpose of this step is to create space for adding 1 bottle of CL45. 1 bottle of CL45 contains 350 milliliters. Therefore, we need to extract at least 350 milliliters of coolant beforehand. We will now begin the extraction process. As you can see, coolant is already being drawn into the 2-liter transparent tank on top of the machine. During extraction, the hose may become slightly compressed due to the vacuum pressure. This is normal. As long as the extraction rate is normal, there is no need for concern. Once at least 350 milliliters of coolant has been extracted, the vacuum extraction function can be turned off. Extracting a little more is fine, as the main goal is to ensure there is enough space to add CL45. Next, remove the machine hose and the radiator cap adapter. Then prepare to pour CL45 into the radiator through the filler neck. Now pour CL45 into the radiator. After adding CL45, reinstall the original radiator cap and tighten it securely. The clamp on the reservoir hose can also be removed so the cooling system returns to its normal flow condition. At this point, the CL45 addition procedure is complete. Now start the vehicle. After starting the engine, the AC must be turned off. At the same time, turn on the heater and set the temperature to the maximum level. The purpose of turning on the heater is to allow coolant to circulate through the heater core. This allows CL45 to clean more thoroughly, covering not only the engine coolant passages and radiator, but also the heater core. In addition, we can determine whether the coolant has started circulating properly by checking if the heater air becomes warm. When both the upper and lower radiator hoses become hot, the heater air is warm, and the cooling fan starts operating, it indicates that the system has reached or is approaching full coolant circulation. Only after confirming full coolant circulation should the official cleaning time begin. Once full coolant circulation has been established, it is recommended to continue the CL45 cleaning process for at least 10 minutes. After the required cleaning time has elapsed, the engine can be turned off. After shutting off the engine, do not open the radiator cap immediately. At this point, the cooling system is still under high temperature and pressure. If the radiator cap is opened directly, high temperature coolant may spray out and cause a risk of burns. Wait until the system cools down and the pressure is released before opening the radiator cap or continuing. After ensuring that it is safe to proceed, move on to the next step. Remove the upper radiator hose and connect the C9 machine for flushing. Next, we will prepare to remove the upper radiator hose. Before removing the upper radiator hose, it is recommended to extract some coolant from the radiator and the area around the upper hose. This helps minimize coolant spillage when the hose is disconnected. At this stage, you can extract as much coolant as possible. As a general rule, extract as much coolant as you can. While extracting coolant, monitor the liquid level in the 2-liter transparent tank on top of the machine. Do not allow the 2-liter tank to overflow. After pausing the extraction, keep the hose system sealed. This preserves the vacuum inside the hoses and prevents excessive air from entering the system. Maintaining the vacuum allows the extraction process to resume more efficiently when restarted. Next, open the waste drain valve at the rear of the machine. Drain the waste liquid from the 2-liter transparent tank into the waste container below. After draining the waste liquid, remember to close the rear waste drain valve. Once the rear waste drain valve is confirmed closed, the vacuum extraction function can be restarted. If the rear waste drain valve remains open, the machine will lose vacuum pressure, resulting in weak suction or failure to extract coolant properly. Once little or no additional coolant can be extracted, you can prepare to remove the upper radiator hose. When removing the upper radiator hose, be aware that residual coolant may still spill out. Therefore, it is recommended to place a drain pan or waste collection container beneath the work area. After ensuring the work area is safe, you may proceed with removing the upper radiator hose. After removing the upper radiator hose, the next step is to install the replacement hose and adapter fittings. The kit includes replacement hoses in various sizes. Select the most suitable hose according to the size of the vehicle's hose connection. When installing the hose, make sure it is fully seated onto the hose connection. Then secure it using a hose clamp. Be sure to tighten the hose clamp securely, but do not over-tighten it. This is because some vehicles use plastic hose connections. Over-tightening may deform or even crack the hose connection. The correct standard is simply that the hose remains secure and does not leak. Next, we will use stepped adapters. 2 stepped adapters will be used in this procedure. One stepped adapter will be installed on the replacement hose side. Another stepped adapter will be installed on the original upper radiator hose that was removed. After all adapters have been installed, reinstall the radiator cap onto the radiator. Next, connect the machine hoses to the system. In this step, the red hose serves as the positive pressure supply hose. The green hose serves as the old coolant discharge hose. As the red hose sends distilled water into the cooling system, the old coolant will be pushed out through the green hose. Pay special attention here. If distilled water cannot be pushed into the system through the red hose, the red and green hoses should be swapped. This is because the coolant flow direction may vary between different vehicle models. If the hose connections are reversed on certain systems, distilled water may not flow through properly. Therefore, before starting the flushing process, always verify that the flow direction is correct. Now open the valve on the red hose and begin supplying distilled water under positive pressure. Allow a brief moment for the distilled water supply process to stabilize. This is because some coolant was already extracted from the system before removing the upper hose. As a result, the system will first refill the space that was previously emptied. As you can see, approximately 1 liter of distilled water has already been delivered from the 11-liter tank. We can now see the old coolant beginning to be pushed out through the green hose. The principle of this process is to use distilled water to push the old coolant out of the system. In other words, distilled water goes in while old coolant comes out. At this stage, the machine primarily uses the positive pressure supply function. This means turning on the machine's motor and delivering distilled water into the system through the red hose. The vacuum extraction function is not used during this stage. Therefore, the waste drain valve at the rear of the machine can remain open during this stage. The purpose of opening the waste drain valve is to prevent the 2-liter transparent tank from overflowing. However, at the beginning, I prefer to keep the discharged liquid in the 2-liter transparent tank for observation. This allows us to clearly observe the color change of the coolant being discharged. When the 2-liter transparent tank is nearly full, open the rear waste drain valve and discharge the waste liquid into the waste container below. If flushing will continue, the rear waste drain valve can remain open. This eliminates the need to constantly monitor whether the 2-liter tank is becoming full. At this point, simply monitor the color of the liquid flowing through the green discharge hose. Continue flushing until the color of the discharged liquid becomes noticeably lighter. The goal is to remove as much of the old coolant and CL45 cleaning solution as possible. At this point, we have used all 11 liters of distilled water. Next, close the waste drain valve. After closing the valve, observe the color of the discharged liquid in the 2-liter transparent tank. As you can see, the discharged distilled water is now nearly clean. If a more thorough cleaning is desired, additional distilled water can be added and the flushing process can continue. Before adding more distilled water, first close the valve of the corresponding hose. This prevents distilled water from being drawn away or lost through connected hoses during refilling. After refilling with distilled water, reopen the corresponding valve. Then restart the process and continue positive pressure flushing through the red hose. You can now see that the discharged distilled water has become significantly cleaner. At this stage, a coolant concentration tester can be used to check the concentration of the discharged liquid. You can also compare the results with photos taken before the service for a before and after evaluation. A sample taken at this point shows that there is almost no coolant concentration remaining. This indicates that most of the old coolant has been flushed out. Once everything has been confirmed, the machine's motor can be turned off. Next, we will prepare to reinstall the upper radiator hose. This is because some residual distilled water remains inside the upper hose and the adapter hose. Therefore, before removing the adapter fittings, it is recommended to extract this remaining distilled water. This helps reduce coolant spillage when disconnecting the hoses. First, close the valve of the positive pressure supply function. The green hose will be used for vacuum extraction next, so there is no need to close the green hose valve. At the same time, the rear waste drain valve must be closed. If the rear waste drain valve is open during vacuum extraction, insufficient vacuum pressure will result. After confirming the valve positions, activate the vacuum extraction function. This will allow the remaining liquid inside the upper hose and adapter hose to be extracted. During extraction, the hose may visibly compress due to the vacuum pressure. This is completely normal. When the hose is compressed and little or no liquid can be extracted, it indicates that very little liquid remains inside the hose. Once extraction is nearly complete, close the green hose valve. Next, disconnect the green hose. Then turn off the vacuum extraction function. Drain the waste liquid from the 2-liter transparent tank. Next, reinstall the upper radiator hose to its original position. When